Okay, so applications. Consecutive integers. The word consecutive means the next one. So if you talk about, oh, our team won consecutive games, that means they won back-to-back games. One right after the next. So consecutive integers are ones that follow each other, such as the next number after 2 is 3. The next number after 13 is 14. Those are consecutive integers. What's the next number? It's like a kindergarten question. What comes after 5? 6. Okay, that's the consecutive integer. They just don't use the term. Consecutive even integers means the next even integer. Okay? So write that in. The next even integer. So the next even integer after 4 would be 6. The next even one after 20 is 22. Consequently, consecutive odd would be the next odd. So the next odd number after 5 is 7, and the next one after 19 is 21. So, going back to consecutive integers, think about the difference between the two numbers. Okay? It's going to be a plus 1. So 2 plus 1 is 3. 13 plus 1 is 14. Think about the difference between consecutive evens. It's all going up by 2. 4 plus 2 is 6, plus 2 is 8, plus 2. And the same thing goes for odd. Well, 2 isn't an odd number. I know that. But the next odd after 5 is 7, and that's 2 away. And then the next one after that is 9, which is 2 more. So when you're going consecutive even or consecutive odd, you're skipping 1 and going by 2. That's very important for what we're going to be doing in these word problems. Yes, word problems. Everyone's favorite thing on that. So, find 2 consecutive positive integers whose product is 156. Okay? Well, we have to first define our variables. So we have our first number and our second number. And we're going to give them variable names. Well, if they're 2 consecutive, and we're not going to use x and y, we're always going to base off one variable. 2 consecutive positive integers. Positive, not even, not odd, just positive. Whose product is 156. So we're going to take x as our first unknown number. If we're talking about consecutive numbers, think about what I said. Consecutive numbers differ by 1. So the next one after x is simply x plus 1. The next number after x is x plus 1. Think about it. If x is 3, x plus 1 is 4. If x is 12, x plus 1 is 13. That's consecutive, and they're positive. Now, separate equation. We have to go back to the original problem. These two numbers are going to be products. You have to think about, what does that mean? Add, subtract, multiply, divide. It means times. Okay? Times. Or multiply. Write that down. Okay? Product means times. Product means multiply. So what we're going to do is we're going to multiply these two and say they equal 156. Now we're right back to what we've been doing for a while. We're going to distribute the x. X squared plus x equals 156. Move this bad boy over. X squared plus x minus 156 equals 0. We're looking for two numbers that multiply and give us 156 that differ by 1. Obviously, we've kind of this setup here. So we're going to factor, obviously, x and x, and we're going to use our calculator. Okay? We need two numbers that go into 56 that are one away from each other. Now, here's a little hint that I just use. When I have a bigger number like 156, I don't have it memorized. Okay? I take my calculator and I take the square root of the number. So square root of 156, I know it's negative, but it's 156, is 12.4. Okay? That kind of gives me a starting point. Okay? I just start somewhere around there. So I'm just going to back off and try some numbers. I could do the ABC method, but this is a pretty easy guess and check with the calculator. Okay? So I just take my calculator and do 156 divided by, let's say, 9. 17. 156 divided by 10, obviously it's going to be 15.6. I'm going to divide by 11. Oh, 14 point something. That doesn't work. 156 divided by 12. I just take my calculator and try. Oh, 13. Well, that's pretty cool. Second square root of 156, like I said, was 12.4. So I started somewhere around there. I went a little bit below and worked my way up. I could have started at 11. I decided to go back at 9 just to check it. But I find out that it's 12 and 13. Okay? Now, I want more here. I want more positives. So this is going to be positive. It's going to be negative. Okay? And I just set them both equal to 0. X minus 12 equals 0. X plus 13 equals 0. Set them equal. I get x equals positive 12 and x equals negative 13. Okay? So, here's my question. These are both right. And you can't say one's wrong because it's negative, because it actually will work out. It just doesn't work for our word problem. We want what kind of integers? Positive integers. Because of that, we're not going to use this one. Even though mathematically it is correct, we're not going to use that one. We're going to use 12. And 12 is x, so x plus 1 is 13. Now, think about it. What's the next negative number after negative 13? It's not negative 14, it's negative 12. So we count to the right. And if you do negative 13 times negative 12, you get 156. So negative 12 and negative 13 are consecutive negative numbers. 12 and 13 are consecutive positive numbers. They give us 156. Okay? Moving on. Find two consecutive possible, positive even integers whose product is 288. Again, my first is going to be x. My second is going to be x plus 1. Oh, plus 2 because it says even. Pay attention. Even means we're going to do x plus 2. Now, the setup's going to be pretty much the same because the product means times. So x times x plus 2 equals 288. Now I'm just going to do the same thing. So I do x times x is x squared plus 2x. I'm just going to move the 288 over now. I know what's going to happen. And now I'm going to factor. Again, I don't know what goes into this. I'm going to take the square root of 288. Well, wait, what? 16 point something. Almost 17. So I'm going to back off like, say, 14. I'm going to do 288. 288 divided by 14, which is a decimal. 288 divided by 15. I know that's not going to work because it's more, close. 288 divided by 16. Hey, look at that. I get 16 and 18. Now, since I want positive 2 left over, I'm going to make this bad boy positive and this negative. Set them equal to 0. And that gives me the answer of x equals positive 16 and x equals negative 18. Well, once again, I want positive, so I'm going to throw out this one and use 16 and 18. But the beauty of this is, we would do it the exact same way if it said negative. We would just end up using negative 18 instead of the 16. And the next even number after negative 18 would be negative 16, because we're going to the right. Area of a rectangle formula is length times width. You've known that since like middle school. How would you write the expression 5 more than x? Well, you got to think about what does this mean? Add, subtract, multiply, and divide. Now, I know you might be thinking, oh, well, more than, that's a greater than symbol. We're talking about the basic 4 operations here. 5 more than x. Literally just translate as you read, as you write. 5 plus x, more than x. What's 5 more than your age? You'd add 5 to your age and find out your brother's age, whatever. That'd be, you'd be x, your brother would be x plus 5, or 5 plus x. And you can write it either way. So go ahead and write that down because it's up to you how you write it. You can literally translate it word for word, okay? Or you can switch it around. How would you write the expression 3 more than twice x? Again, this is like literally survival translation. Because this is going from one language to another, English to math, okay? So I'm down in Mexico on vacation. I need to hit the bathroom really quickly. I don't have time to, look up my book, every single word, and say, excuse me, ¿dónde está el bathroom? Baño. Baño, por favor. Be very friendly, nice accent, all that stuff. No, I look at the bathroom and I go, ¿Dónde baño? They're going to know what I'm talking about. It's not going to sound good, but it's a literal. ¿Dónde baño? Where bathroom? Ugh. Point me direction, right? Literally word for word. Not pretty, but word for word. That's what we're doing here. Word for word translation. 3. That was tough. More than. Twice x. 2 times x. Twice means 2 times, okay? Literally. That's it. 3 plus 2x. You can also write 2x plus 3. Doesn't matter. But that's a literal word-for-word translation. How would you write the expression 4 less than x? This one's tricky. You've got to be careful with this one. A lot of times people write this. 4 less than x. No. Think real world. Think about you and an older sibling or older friends. 4 years. If you're 4 less than them, okay, and they're 18, you're 14, okay? Well, think about that. In that case, they're 18, you're 14. If you did 4 minus 18, you'd end up with negative 14. That's not right, is it? So if you're thinking about their age, you'd want to say 18 minus 4, which is 14 years old. Okay? So you're 4 less than x. You're actually going backwards on this one. So this one is going to be x minus 4. The most common mistake in translating 4 less than a number is writing 4 minus that number. And that's not how you do it. You have to reverse it. Because you're 4 less than them. You're referring back to that starting point. And that's a key point. All right? The length of Joe's kitchen floor is 4 feet more than the width. The area is 117. What's the length and width of his kitchen floor? Define your variables. Well, we're going to say length and width. Now, it says the length is 4 more than the width. You got to ask yourself, what's the starting point? What's being compared to what? Well, length is being compared to width. So width is actually going to be our starting point. That's what we call x. You usually want to look for this word here and make that thing following it x. That's a little hint. Okay? Susie is 2 years more than 3 times Becky's age. Becky's going to be our reference point. You could, I'm not saying you couldn't, you could make length x. You just have to go the opposite direction. But the most common sense, easiest way to do this is make that x. Now, the length, this right here, is 4 more than the width. The length is 4 more than the width. You literally go like that. Now, we just said area is length times width, so we're going to do what we just did. X times x plus 4 equals 117. X squared plus 4x minus 117 equals 0. Alright, so we're going to do the same thing. Now this time, notice though, we want our numbers to differ by 4. I'm still going to do the same thing. I'm going to take my calculator, I'm going to do the square root of 117. And I find out it's 10.8. So since I'm going to be different by 4, I'm going to back off a little bit. I'm going to start back down at 8. Even 7, just to be safe. 117 divided by 7. Decimal. 117 divided by 8. See how long this takes? Decimal. 117 divided by 9. Ha ha! 13. Are 9 and 13 4 apart from each other? Yes, they are. I want more left over. There you go. X equals 9. X equals negative 13. But when it really comes down to it, 9 feet by 13 feet. I guess I should have written that down there. But that's the dimensions. The dimensions are 9 feet by 13 feet. I could be more specific and say this is the width and this is the length. I don't have to write by. I can just say width is 9, length is 13. You can do it either way. Does that make sense? Okay. Projectile motion. This is what we've been dealing with for a long time, just without a word problem. This is the classic throwing a ball in the air, shooting a rocket up in the air. Okay, so, I don't know what happened to the board. So I'm throwing the ball up in the air, throwing a rocket in the air, shooting a rocket up in the air. H is my height at any time in the travels. Okay? So remember, it's going to be launching and coming back down to Earth. VO is my initial velocity. T is my time. And HO is my initial height at time 0. In other words, the starting point. So if I throw something from my arm, okay, I'm just throwing a ball in the air. I'm 6'2". I'm throwing it from my, above my head, maybe 6.5 feet. It might be, H at the end might be 6.5 feet, 7 feet, something like that. If I was throwing something off of a cliff, it could be 85 feet, 100 feet, whatever. Throwing it up in the air off a cliff down to Earth. All right? And how fast I throw it is going to be the coefficient of T. So a diver jumps from a diving board that's 32 feet above water. The initial velocity is 16 feet per second. Write the position for the diver at any time t. All you're doing this means is put these numbers into this equation. So his height at any time is going to be negative 16 t squared. That doesn't change. This is the master formula. Negative 16 t squared plus this number here, velocity, goes here, times time, and then plus 32. That's his feet, how much he was above water. Starting at 32 feet, launching off the board at 16 feet per second, and getting into the water. And that's all you have to do there. That's all I wanted you to do, set up the equation. And last but certainly not least, Jason, jumped off a cliff into the ocean in Acapulco. While vacationing with some friends, his height as a function of time can be modeled by this. So where t is time in seconds and h is height. How high is he above the water at 3 seconds? Well, again, where is he starting? He's starting at 480 feet. That's how high the cliff is. He's traveling 16 feet per second. And everything else is the way it is. How high is he at 3 seconds? Well, 3 seconds is time. Okay? We want to know when the time is 3 seconds. Okay? So here he is up on his cliff. Yay! And he dives off into the water below. Some waves. And you can draw the picture. So he's going to dive. This is 480 feet. Right there. Okay? We're going to know, time travels this way, right? So at 3 seconds into his journey, where is he, height-wise? All we're going to do with this 3 is plug it in here and here for time. So, height as a function of time. In other words, height changes as time changes. That's what this HT means. Remember we talk about why do we have functions? Why don't we just say y equals? This is why. For real-world equations, height as a function of time. So, negative 16, 3 squared, plus 16 times 3 plus 480. Now, we have two choices. We can crunch the numbers. 3 times 3 is 9 times negative 16 plus 16 times 3 plus 480. We can do that. We can also enter this into our calculator, y equals, okay, and look at 3 on our graph. Doesn't matter, okay? So 9 times negative 16 is negative 144. 16 times 3 is 48. So 48 minus 144 is negative 96. So 480 minus 96 is 384 feet. 384 feet. In 3 seconds, he's at 384 feet. Now, Jason will hit the water after how many seconds? Well, the water is 0 height. So that means we're putting a 0 here. We're trying to find out when is he going to hit 0. So now we're factoring. With these huge numbers, I would highly suggest using the ABC method. But I would also see if I could reduce first. And I can't. I'm actually going to make these numbers smaller to make my life easier. So what I'm going to do is I'm going to factor out a 16 or negative 16. That's your choice. I personally want to factor out a negative 16. And the reason is it leaves my t squared positive. And that just makes life a little bit simpler to deal with the negative t squared. So when I divide my negative 16, I get positive t squared minus t, or 1t, minus 30. Now, my numbers are 1, negative 1, and negative 30, which are much easier. I don't even need to really use the ABC method. I can just guess and check, because I need two numbers that multiply and give me 30 that differ only by 1. The next time it pops out at 8, 5, and 6. Now you have to be really careful here to make sure you pay attention to which one's positive and negative, because it's going to change the time when he hits the water. Since I want more negatives, that's negative and this is positive. So when I set them both equal to 0, I end up with x equals negative 5 and x equals 6. That's my answer, but I cannot go back in time. But if I would have made a mistake up here and switched them, I would end up with 5 seconds. And we're going to see how that does not play out. So I'm going to pull up the calculator and enter this one in, and then come back. So here I've entered it in. I'm going to hit graph. You know, it's off the chart because it's at 480. But we want to just see the table of time starting at, oh, sorry, I have half seconds in here. So at 0 seconds, he's at 480. At 1 second, he's at 480. But look at here. 5, he's at 160 feet, and 6, he's at 0. So that's why if we would have made a mistake with the negatives and positives and said he was at the water at 5 seconds, he would have been early. So he actually hits the water in 6 seconds. Now we're going to really quickly graph it. So here's time down here, and here's height. Now we're going to go up, skip a few lines, 100 feet, 200, 300, 400, 500. Now he starts at 480 feet. So we'll just kind of estimate that right there. We did see that in 1 second, he was also at 480 feet. So we need to find out what his vertex is. So we're going to go back up here and do ABC. Negative 16, 16, 480. Now we're going to do the opposite of B over 2 times A. Well, that's negative 16 over negative 32, which is positive 1/2. So that means in half a second, somewhere here is where he's going to hit his highest point. So I'm going to use a calculator. Now I'm going to go back in and have what I had before and go up by 0.5. Now when I go to my graph, my table, there it is. 0.5 seconds, he's at 484 feet, which is just going to be slightly above. And at 6 seconds, he's going to be at 0. And we could look at the graph for some other ones, but this is about what it's going to look like. Right there, using the calculator. And that's his graph of his cliff diving.